At a power station in Berlin, Germany, visitors find a shining piece of machinery that looks out of place in the building. Its silver pipes and containers hold a substance that reportedly could become a major ingredient for producing power in the future. Vattenfall, the station's operator, says this form of energy would not depend on traditional fossil fuels such as oil or coal. The company, working with a Swedish company called SaltX, is testing the use of salt to store heat. Yet it is not the kind of salt you add to food. Heat-produced energy represents more than half the power Germany uses. If it works well, the salt-based energy storage system could help solve a problem presented by renewable energy sources, such as wind and the sun's energy. The problem is that renewable energy sources are not completely dependable. They sometimes make too much and sometimes too little power. E.ON, another German power company, recently reported that wind and solar power produced up to 52 gigawatt hours of electricity during daylight hours on Monday, April 22nd. Germany's energy usage at the time was just 49.5 gigawatt hours.
Hendrik Roglin heads the salt storage project for Vattenfall. He told the Associated Press that power companies are able to produce twice as much energy as Germany needs through renewable sources. However, they cannot do so continuously. With many facilities like this one, in theory, you wouldn't need gas or other fossil fuel backups, Roglin noted. Berlin's Reuter power plant supplies heat to 600,000 households in the German capital. Now the plant is adding a salt-like substance called calcium oxide, also known as quicklime, to its power-generating efforts. Vattenfall and SaltX have been making use of a simple chemical reaction that happens when quicklime becomes wet. The salt-like particles collect the water, becoming calcium hydroxide, and releasing large amounts of heat at the same time. The calcium hydroxide is then cooked, removing the water and changing it back into calcium oxide. The process operates in much the same way batteries do. But instead of electricity, the system stores heat. SaltX says it has also created a way of covering the quicklime with small particles known as nano-coating. This prevents it from sticking together after several heating and cooling cycles. Roglin says the process can take in 10 times more energy than water, which is currently used for power-to-heat facilities. And unlike containers of hot water, which slowly cool down over time, the system can hold the chemically trapped energy for far longer. Need heat? Just add water. It makes total sense to try this because storing energy is a hugely important step in the future, says Kai Hufendijk. He is an energy economist at the University of Stuttgart and was not involved in the project.
The Swedish company SaltX claims that the system can produce temperatures above 500 degrees Celsius. Hufendijk noted that if this is true, it also makes the process interesting for industrial uses, such as food processing. SaltX adds that the calcium oxide currently mined in Finland could be safely used more than once. That makes it more useful than some battery technologies that use rare or toxic materials. Simon Allen is a representative of SaltX. During a recent visit to the Reuter power plant, he said that this is a solution to energy needs that is available in a short amount of time. If your ambition is to be fossil-free within a generation, you have to consider alternatives to reach that, he told reporters. Yet Hendrik Roglen of Vattenfall is waiting until the end of the year to see the results of the tests. The Berlin-based project can currently store enough energy to heat about 100 large houses. But SaltX says the facility could easily be expanded and provide heat to any of the homes or offices already connected to the city's heating system. Such systems, made of pipes pushing hot water or steam from power plants to homes and businesses, exist in many European countries. They also exist in China, Japan, Canada, and the United States.
Experts agree that a number of technological solutions will be necessary to take the place of fossil fuels. Some already exist, while others are still experimental. U.S.-based automaker Tesla has already shown that it can provide large lithium-ion battery systems to operate electrical grids. Moving away from nuclear, coal, and gas is a big goal for a heavily industrialized country such as Germany. The government has set a date to close all the country's nuclear plants by 2022 and stop burning coal for electricity by 2038. Gas will be a backup technology until a way is found to depend wholly on renewable sources sometime around 2050. The German plan is being closely watched by other countries studying how to meet the Paris Climate Accord, signed in 2016. That agreement aims to keep warming in the Earth's atmosphere well below 2 degrees Celsius. I'm Ashley Thompson.
And I'm John Russell.